All right, four physical changes of ethanol are listed. Which do the particles move further apart?
Evaporation oil.
Yes. An atom of X contains five protons, six neutrons, and five electrons. Okay, remember X, the nucleon number is 5 plus 6, which is 11. The proton number is 5. Because proton and electron is the same, it's an atom because it's neutral. Get it? Yeah? All right. Which statement of X is correct? X has an atomic number of 6. No,
No, it's fine.
it's 5. Has a nucleon number of 11. Yes. In group 2, write down the electron arrangement 2, 3. No, it's group 3. Second period. Yes, correct. So the answer is 2 and 4. Okay, this one you have to write down nitrogen is 2, 5, hydrogen is 1, meaning, yeah, C. A lot of students do D because they think it's 2 here. No, it's only 1. Okay, don't make that mistake. Which structure does silicon oxide as giant covalent diamond? Substance P conducts electricity when solid. Okay, if it conducts electricity when solid, it has to be a metal. A metal has free moving electrons.
So three only.
Yeah.
Mm.
Okay, chemical change, you must see that this is physical change. This is just dissolving.
Oh,
This is just dissolving. This one is a precipitation reaction. This one number our teacher next time. It's a precipitation reaction. Which sample contains the largest number of molecules? You have to calculate each and every one. That means mass over molar mass. Mass over molar mass. Mass over phosphorus is what? 31 times 4. Huh? Molar mass. And this one is volume
wait, what was the answer for 6?
B.
Oh,
This one is volume over molar volume. Get it? These three is mass, so you take mass over molar mass. This one, they give you a volume of gas. So it's volume over molar volume. So you just have to count who has the largest number of moles. And the answer is it A?
yeah.
Mm.
Yeah.
So only one that's 1. The rest are less than 1. Okay? Okay, number 8. Titration. Okay? In order for us to do titration, we need to know only, remember, titration is here I calculate MV over 1000, here I calculate MV over 1000. So I only need MV over 1000, MV over 1000. No need to use molar mass.
Oh, no.
Today's concentration of a sample dilute reaction, the parameter is showing. Okay, so you only need concentration, volume, and volume. So the answer is E. Hey, sorry, I cannot see R. So, it's yeah. Can I?
Yeah. Wait, let me write it.
You only need M and V. V, and then you find the other M.
Please.
MV over 1000, molarity is concentration what?
Okay.
Do you understand? Got it?
Yeah.
Okay. Right. This one you need to draw. Not even understand. Okay, you just look at it. It's not gonna help. So experiment one, you do electrolysis using graphite. In experiment two, you do electrolysis, but you use copper. Both also use copper to sulfate. Okay, can? So remember, I told you already, copper, hydrogen, sulfate. Okay? In experiment one,
Choose
anode, you choose
hydrogen.
anode.
Oh.
You choose anode is anion.
Oh.
So you choose hydroxide, correct lah? Cathode in experiment two, do you choose hydrogen? No. Cathode for experiment one and experiment two, both you choose copper. Remember? Copper is transition metal, so that's why no. In experiment two, the half equation for anode, no, this one's not the equation for anode. No, this is for cathode. And experiment two, half equation for cathode is this, no. Experiment two and experiment one, both the cathode is like this. Do you remember? So the answer is A.
I thought zero cathodes, so I chose originally I chose.
Okay, you have to be very careful. Okay, is that all? Okay, so that's the first one. Okay, second one. Which two gases would diffuse at the same rate? Ha ha. CO and CO2. CO and N2. So the answer is B. You calculate the molar mass. Cl2, F2, N2, and O2. Everybody has different molar mass except for these two are both 28. Right? Okay. A student measures the time taken for 2 grams of magnesium to be dissolved. What apparatus is essential? So time, so stop clock, measuring cylinder for this, yes. Balance is for this, yes. 1, 2, 4.
I wrote 1, 2, 3.
Balance is to measure how heavy. Okay. Chromatogram. I taught you chromatography right last time. Yeah. Okay. What is the RF value? RF value is you take the distance traveled by the spot over the distance traveled by the solvent. Yeah. So you take 3/4 to find the RF value. 3/4. Okay. Okay. Two different elements. They have the same nucleon number. Okay. Two different elements. If the nucleon number is the same, that means the proton number is different lah. Okay, maybe it's 5, 6, but both are 12, 12. I mean the other way around lah, but you know what I mean, right? Okay. They have the same physical properties, no, because they're not in the same group. Okay. Same number of electrons, no, because the proton number is different. Different groups of the periodic table. Uh, different groups. Yes, they are in different groups. Okay, because they have different elements that have the same nuclear number. Okay. They have the same relative mass, 12, 12. Because they said same nuclear number. Nuclear number is the relative mass in grams. Remember? Yeah.
Different groups.
You decipher for a while, think for a while, let it absorb into your brain.
But they all might be in the same group, right?
How can they be the same group? They have different proton number. How can they be the same group? They have to be eight electrons different in order to go back to the same group. If they have 8 electrons different, 8 protons, 8 electrons different, how can they come back to the same nuclear number? How is it possible? I want you to find 2 elements in the periodic table with the same same nuclear number.
I don't think that.
Look carefully, you look carefully. What's the guy? Carbon. Cobalt, is it? Boron and are they both 12?
No. Boros 11.
Guys, look carefully. Okay. So look at this, cobalt and nickel. Are they in the same group? How can they possibly? Cannot. You get it or not? Can you see how far apart they are?
One block.
Mm. So can they possibly come back one circle and come back to the same group? Cannot. It's very, very hard. It's almost impossible. Get it or not?
Get it now.
Okay.
Oh my god, I.
You got extra food for him to eat or not? Okay. Next time we bring extra food, okay? No. All right. This one is silicon because it's two different elements.
What?
This one is one element only, so it's diamond, and this one is graphite. C. No, he was there.
What?
Okay.
A. 6 is A.
Six is A, correct. Seven?
C. C.
Okay, this one is a solid. It's insoluble. This one is aqueous. The rest are aqueous. A. I will be teaching you this next chapter.
Why is B A
Because I thought it's soluble.
Oh, barium chloride is liquid.
Okay, Ken?
Then
Ay, so funny lah. Yeah. Methane and steam react. Okay, so if 0.5 mole of methane react completely with 0.5 mole of steam, what is the volume of carbon monoxide and hydrogen produced? Remember, if this is 0.5, this is 0.5, and this is 1.5. Okay, so volume is 0.5 times 24. This one is 1.5 times 24. Volume. So it's like 12 and 36. D. Volume. Okay, do you understand now?
my memory is not slowly coming back.
It's all coming back to me.
No, what?
So sad. Okay, the compound of element X has the formula of X2O.
Copper.
So the total is 144 copper. Okay. So you take 144 minus 16 and then divided by 2.
Anything with maths.
Diagram shows that electrolysis of concentrated hydrochloric acid and concentrated aqueous sodium chloride.
Oil.
Okay, so hydrogen is always produced at the cathode. So it's 2 and 4.
No way, I totally lost the entire one.
Yes, this one is negative. Negative is cathode. Okay, last question. The diagram shows electrolysis of aqueous copper 2 sulfate solution using inert. Okay, remember, electrons flow in the wire, ions flow in the solution. So movement of electrons is not this too. Okay, wait. Cathode receive electron or release electron?
Receive. Oh,
Okay, so there's 11 here, and then the previous one got 10, is it? The previous one had 9. Okay, so 20. Altogether 20. How much you get? Count.
and 1, 2, 3, 4, 5, 6, 7, 8, 9. 12, right?
Yes. So,
Yeah.
18. Hey, you got 6 wrong. 14. Okay,
We need to do
okay
more
lah.
of this. We have to do more of this.
Closer to exams, I'll give you more. But do you understand the concept of what you're doing? Do you get it now or not? Huh?
Seriously.
Which question? Question 8. This one? Ah? No, that's the second one. No. MV over 1000.
Molarity and volume. Volume of both and molarity of HCl.
Molar. MV over 1000 is amount of moles. In order to calculate, you just need to know MV over 1000. Right or not? Correct? Uh-huh. So now you have 4 things. MV of acid and MV of alkali. So you only have one unknown. Get it? You have one unknown. That means either your M or your V you don't know. So the one that you're unknown now is dilute aqueous sodium hydroxide. So you don't know this one. You don't know the M of sodium hydroxide. So you just need the MV of hydrochloric acid and the V of sodium hydroxide, then you can find the answer lah. That's it. Get it now? Answer or not? You sure you answer or not?
Wow.
You take a while
Eat the food.
to absorb it into your soul. Can?
Oh, no.
Can I? Okay. Now I want you to look at this. This is called your syllabus content. Now the reason why today we had a slight hiatus from doing work is because we cannot just learn without doing exercise and then think, oh, I know everything. Okay? All right. So this is what we have done so far. Okay, I want you to look at this just to give you an overview. So this is your syllabus. You are taking exam 2026 next year. Lah. Okay. So the topics that you have done, the topics that you have done,
1, 2. 1,
okay,
6.
1, 2, 3, 4. Oh, we have done until electrochemistry. No, we have done 5 also. Energy in, energy out. I did already, right? The one, the bond energy.
Let me everything on the way.
Rate of reaction, we did, right?
No, we haven't.
See.
We only got to
Electrolysis.
electric.
Electrochemistry. Okay, so I need to gear up a bit. All right. These three chapters, these two chapters are connected to each other. They're very, very easy. They're connected to each other. Okay, can good. And then after that, we will learn acid-base salts. Okay. Okay, come. Let's do this. Okay, now. So today I'm going to teach you something called energetics. Okay. Now let's say I have X react with Y to form XY. Okay, let's say this is a reaction. All right, so you should know that. How is it?
Not with my use.
Okay, never mind, not important. Okay, so you should know that. No, I'm telling you, when they give you a question, you know X and Y lah. These are just example. And X has a bond, right? Not?
Yeah.
Okay, I am telling you now, Y and Y has a bond. So this and this react, and then they form XY, like that. Okay, can Okay, so what happens here is this is the reactant and this is the product. Okay, in order for these guys to react, the first thing that must happen is I must break this bond. I must break up first, only they can date new people, right? Cannot simply date new people while not to break up, right? Or not? Okay. So what happened is, in order to have a reaction, in every reaction that happens, I must always first break bonds. I must always break bonds first. Okay, I must always break these bonds first. And in order to break bonds, I absorb energy. Or basically, energy is in first at the start. Can you understand? Okay. And then after I break bonds, I have free X and Y like that. Now they are free. Okay. And then they will do what? They will form bonds. When they form bonds, they will release energy. Okay,
Is
can?
there a chance they
So, no, cannot.
what?
That's something else. That's something else. Okay. So to form bonds, you release energy. And though also it's known as also energy out. I simplify for you, energy out. In any reaction in the world, it's always energy in first and then energy out. Okay. If more energy in, if overall, let's say 500 kilojoules to break the bonds, but only 100 kilojoule to release, to form the bonds. So more in or more out? More in is called endothermic. Okay?
Oh, this is the specific.
Yeah, so temperature goes down. If let's say in this reaction, only need 100 kilojoule energy absorbed to break the bonds, and then 5,000 is released. More energy in or more energy out? Out. And it's called exothermic.
Okay.
Okay, but what you must understand in any reaction, first break up first, then only can form. Okay, sometimes break up a lot of energy, so not much energy out. Sometimes very little energy to break up and a lot of energy out. So depends. So that forms two different kinds of reactions. Okay, can? Okay, can you write this up? Actually, no need. Okay, I will send you later. So what you need to understand now is, okay, later I'll send you this. Okay, so far so good. Can understand? Very simple, right? Very simple concept, right? Okay, now in any reaction, so we start again with X and Y. Okay, x2 plus y2 become 2xy. Let's say in is 50 kilojoules and out is 150 kilojoules. Okay, so we draw something called an energy level diagram. So first you have the reactant. Reactant first, okay. How much energy in? 50. Okay. Going up, right? So positive. And then energy out, how much? 150. Okay. And then here I have my product. Got it? So overall, how much change?
100.
100. It's only from here to here, right? And the energy is going up or going down?
Down.
Down. So this is called enthalpy change. And if it's going down, it's negative
And how
enthalpy change. Okay? So I'm going to write it out. This is negative 100 kilojoule. So this means enthalpy change or energy change. And this value of negative 100 means it is a exothermic reaction.
release heat.
Release heat. Heat is released to the surroundings. Okay, now when I'm doing this experiment, of course, I cannot see going up, going down. I cannot see, right? But what I do is I put the reactants together and X2 plus Y2, and I take a thermometer and I stir. I feel the temperature go up. If I put my hand here, it will feel warm. The temperature goes out because more heat is released. Okay? And now the product has more energy or less energy than the reactant. More. So who must happen first? In or out must happen first? In. Must have in, right? Even though out a lot of energy, I must still have that in first. So the energy in is the minimum energy that must happen before a reaction that can occur. So this minimum energy in is called the EA, activation energy. Activation energy is the minimum energy absorbed before a reaction can occur. Okay, let's say I only give you 49 kilojoules. Can happen? Cannot break bonds. I only give you 30 kilojoules. Can or cannot? Cannot. So I must have energy in first. Give me an example of an exothermic reaction. Burning, combustion. Can something just burn like that, or do you need to first light up the light up first, right? You cannot just burn, oh, burn like that. No, you first have to light a match. That lighting up a match that you're giving is called the activation energy. Okay, so this one shows energy in and then energy out, but overall
It is out.
it's just out. So it's just x plus y, x2 plus y2, and then it's just out 2xy. So this is the simplified version, negative 100 kilojoule. Can you see that? Okay. So this is called exothermic. Got it? Okay. So exothermic very easy lah. Okay. Endothermic is just terbalik lah. Endothermic is just terbalik lah. Okay. So endothermic like this.
Why if the surroundings don't have heat? Then it don't react.
No reaction.
So
So basically, if nobody lights something on fire, will it burn?
no.
No. Yeah.
Because
Suddenly went dead.
worst stops.
It suddenly decided not to respond. So if let's say okay, same concept. Let's say in is 1000 kilojoule, let's say lah, and out energy release is only 500 kilojoules. So this is endo or exo?
And
Endo. So this is called an energy level diagram. So now my EA is a lot. It's 1000. But I only release 500. Okay, so my change in energy is from here to here. How much?
One. If I
Positive 500. Can you see the difference? Okay, is this still the activation energy? Yes, it's still. But now the product has more energy or less energy than the reactant?
yes.
Huh? Product.
Oh, more.
More, because it's endothermic. Okay, so endothermic reaction, the enthalpy change is positive. Get it? And if I take thermometer and I stir, the temperature will go down. Okay. Examples of endothermic reaction is, there's a cooling pad where you break the thing and then it becomes cold, and then you put it on your wounds. That's endothermic. Okay. Example exothermic is heating. All right. Okay. I will send this to you. Let me copy this down. Okay. I'll send this to you. You copy this down later. Okay. Can. Okay, so what we need to learn is how to calculate energy. They will give you bond energy. That means for everything, right, they will give you the bond energy. Okay, I give you an example. Okay, I give you an example like this. All right, methane burns in excess oxygen. Okay, so what you actually need to know is
Oxygen.
this is methane. Wait, this is methane, right? You need to know methane actually looks like this, CH4. Okay, and then oxygen O2. How many oxygen? 2. Okay, so this is energy in, right? Not absorb, energy absorbed to break bonds, right? Okay, this is a CH bond. How many CH bond do you see? 1, 2, 3, 4. Every single CH bond is 410. These numbers no need to memorize. Nobody's so free. Okay, so 4 times 410 is to break this bond. Okay? And then oxygen, how many oxygen do you see? One bond, 2 bonds. This O is 496. So plus 2 times 496. This is your total energy in. Can you understand?
Okay.
All right. Okay, so how much does that give you? 4 times 410 plus 2 times 496. 2632.
Wow.
Okay. Now, energy out is CO2 and H2O, right now? Okay. So, energy out, CO2. Okay. Teacher, how I know CO2 is this kind of bond? That's why we learned last time, covalent bond. That's why you need to know everything that happened last time. And H2O, what is the bond? HOH. How many H2O? 2. Can you see that?
Yeah.
Okay. 1, 2, 2 times CO 805 plus 1, 2, 3, 4. 4 multiply 460.
Good.
Okay. Get it on 2 times 805 plus 4 times 460. 3450. Okay. So what is my energy change? What is my enthalpy change? In minus out. Okay, don't tell me positive, negative yet. You just say in minus out. In is 2632 minus 3450. Will it be positive or negative? Do you write negative or do you try and change it to positive? No, if it's negative, you must write negative.
Negative.
Negative 818 kilojoules per mole. So this value is negative, so that's why it's a exothermic reaction. Can you understand? Can? Okay, so this is what I'm gonna make you do next week. Okay, and this is like half of the chapter already.
What?
Okay.
No.